All right, in the last lesson we learned how to draw an octagon within a square. Now what I'm going to do is I'm going to show you how to draw an octagon in a circle. So, and this is oftentimes a problem that you will encounter almost sometimes more frequently than you would be working with a square. So I'm going to start out here by just drawing a circle of a convenient size on my paper like this. First step. Second step, I'm going to draw a diameter within this circle. Notice I've got that little dimple right there where I place my compass. So I'm going to put my pencil right in that dimple. I'm going to move my straight edge up to the pencil, and then I'm going to sketch in lightly my diameter. The next thing I'm going to do is I'm going to erect a perpendicular to that diameter, and I'm going to just open my compass right on up to the full diameter of the circle. I could go any width here, but I'm going to keep my intersection points outside the circle so I don't clutter up the circle, the interior of the circle. And what I'm going to do is I just lightly draw an arc up here, shift the compass over to this side. In fact, let's go ahead and call this A, and we'll call this B, and we'll call this C for the center. Okay, so I've set my radius to AB. I've struck an arc from B as center up. Now I'm going to strike another arc from A, using A as the center, swing that arc up and get my intersection point right up here outside the circle. And we can call that point D. Now I'm going to take my pencil and my straight edge, and I'm going to hold the pencil right on, carefully on point D, move my straight edge up to it, and I'm going to carefully eyeball and get it lined up with point C. Then I'm going to draw in this vertical diameter of the circle. So I now have the circle divided into 4 sectors. This is the quadrature of the circle. So now I'm going to proceed to create an octagon. So let's go ahead and name, we'll call this point E, we'll call this down here point F. I can start anywhere I want, any one of these points, but I'll start with B right here. And I'm going to open to BE. And I'm going to swing an arc out here like this. Then I'll move my compass over to E as the center without changing the radius of my compass, and swing a second arc, getting that point of intersection right there, which I suppose we can call, where are we at? We'll call point G. And then I'm going to do the same thing over here. Again, being careful not to change the setting of my compass. I'll draw a piece of an arc up there, and another piece of arc here, giving me still another point of intersection there, which we'll call H. Now, take my straight edge like this. I'll start with H, hold my pencil on the point, move my straight edge up to it. Now I'm going to carefully swing it around and line it with my center C right here, and I will draw in another diameter this way. I'll do the same thing coming from this side. And it helps if your pencil lead's not broken. And I'll draw that in this way. And you'll see what I've done. I have divided my circle into 8 sectors. Each of these points now can become the corner of an octagon. I'll use some red ink here, and then I will draw in the edges of my octagon right around the circle. that. Isn't that nice? Okay, so now you have the technique for creating an octagon within a given circle, or you can create an octagon within a given square. You'll notice that when we created the octagon in the square, if you review that particular tape, you'll notice that the width of the octagon, the square defined the width of the octagon from center of face to center of face. The circle defines the width of the octagon from one vertex to the opposite vertex. So obviously there would be two different ways of measuring the octagon, from the center of each flat face across, which is going to be slightly less. As you can see, if I were to draw a line, and I'm going to go ahead and do that. Let's get the center of one of these faces. Let me get my small compass here, and I'll show you how, if we were actually wanted to go a little further with this and divide it into a 16-sided polygon, we could do so. But just by doing that, I can get the midpoint of the face. Now, clearly you can see that if I were to draw this across from the center of one face to the center of the opposite face, that is going to be a little bit shorter than the diameter of the circle. Let's actually set it out here. I'm going to set my compass to that midpoint to midpoint of faces, and then I'll put it here on the diameter of the circle, and you can see it falls short. And so if you're actually attempting to solve a practical problem in design or building, you know, you're going to want to determine ahead of time which dimension of the octagon you're going to use. Will it be from center of face to center of face, or will it be the diameter of the circumscribing circle? And I showed you last time how to now do a nice octagon, or an octalfa out of this. And I'll show you quickly here another version of an octalfa. And this one, in the one we did last lesson, we skipped 2. We started out and drew a series of lines, skipping 2 of the vertices. So now we're going to try it by just skipping 1 and working our way around and see what happens. Let's get this one in there. We'll use green for contrast, so we'll skip 1. We'll skip 1. Skipping 1. Skipping 1. And we end up with a square contained within the octagon. We'll go ahead and do it again. And we have this figure. Now, of course, what's interesting about this figure is we now have another enclosed octagon, as you can see, with 8 corners, 8 vertices, and each of those vertices is going to roughly coincide, or should precisely coincide, with the midpoints of each face. And then, of course, within that, we can draw another series like this. What we've done here is to lay out the basic pattern for developing the ad quadratum system of Masonic geometry. As you probably have learned in some of the lectures or in the discussions, there were 2 systems of Masonic geometry, predominant systems in use, the ad quadratum and the ad triangulum. The ad quadratum was based upon the square and the right angle and its derivatives, such as the octagon. The ad triangulum of the triangle was based upon the equilateral triangle and the angle of 60 degrees rather than the angle of 90 degrees, and its various derivative forms such as the hexagon. And then when you combine the ad quadratum with the ad triangulum, you get the dodecagon, which is the 12-sided figure, which merges the properties of the two systems together. And we will be looking at that in depth as we go on, and we will learn how that was utilized for to create various architectural masterpieces through history.